Okay, so the one thing we haven't looked at yet, and I was kind of alluding to it on the quiz, is that we haven't done any with having polynomial on the bottom. So, I mean, you have the option, so say you had y equals 2x over 3, or let's say, yeah, 2x over 3x, or let's just go 2 over 3x squared. You have the option of just going, well, y equals 2 thirds x to the negative 2, and then you can go find the derivative of that, okay? And you'll always have that option even after I show you this quotient rule. But the quotient rule sometimes is going to work better, and when you get good at these, you can start to say, no, the quotient rule will be better there. But I'm going to teach you how to do this now, leaving it as a positive 2 in the bottom, and then just deriving it from that, okay? But always remember, and maybe if you do have extra time in your test, maybe make it a negative exponent. Use the last rule we learned, and then see if you get the same answer. So if you have f over g, it says find the derivative of that. The way you do that is you go f prime, or derivative of f times g, minus the function f times the derivative of g all over g squared. Okay, now doing the other notation, find the derivative of f of x over g of x. This would be, so g of x times d over dx of f of x minus f of x, the derivative d over dx of g of x all over g of x squared. So this one, you cannot reverse it and get it right, because then that subtraction sign, the negative should be with the second one always. Now stated in words, it's the derivative of the top times the bottom, just leave it, minus, leave the top, times the derivative of the bottom, all divided by the bottom squared. Okay? So I'm just going to give you a little thing to help you remember that, and this is what I always use when I'm going through. So go low, D high. Okay, these are supposed to have little, so it's like a little song. Low D high minus high D low over low squared. So low D high minus high D low over low squared. Okay? That's how I keep it straight. Sometimes the more ridiculous, the easier it is to remember. So that means the low times the derivative of the high minus the high times the derivative of the low over the low squared. No, those aren't minus signs. We'll put a big minus sign right here. If you really want, you can take these out if you're going to mix them up with minus signs. But okay, now this is one where you could, if you wanted to just take this and make it x times bracket x minus 1 to the negative 1. And you could do product rule. Okay? But let's do it using the new one, see how it goes. Okay, so low would just be x squared minus 1 times the derivative of the high would equal 1 minus high times derivative of the low is 2x all over low squared. Okay, so we can simplify this a bit. It would be x squared minus 1 minus 2x squared all over x minus 1, or x squared minus 1. Yeah, so that would give us negative 1x squared minus 1 over x squared minus 1 squared. Yeah, if you took out a negative 1, that would make that other one positive 1. So I can't go more than this. But I don't have an x squared minus 1 up top. I have a negative x squared minus 1. Because this is a negative x squared. If this was an x squared minus 1, I could. No, but that has to be in both of them. Can't just do one. Yep. I say a little bit of knowledge is a dangerous thing. Okay. Number 2. Okay. This is one like we did yesterday, where you differentiate and then you just sub in. Okay, so if we have f over g, and we want to find the derivative of that, so f is, so low d high, right? So g of x times f prime of x minus high would be f of x minus derivative of low be g prime of x all over g x squared. Okay, g of x is 6. So we've got 6 times f prime of x is 3 minus, actually I'm going to want to use brackets here. Okay, and then I have f of x is negative 4, and g prime of x, sorry, is negative 2, and that's all over gx squared, 6 squared. So this gives me 18 minus 8 over 36 which is 10 over 36, which equals 5 over 18. Okay, state the domain. What's the domain of this one? X cannot equal 9. Now some people have a hard time just looking at that, so you can always do this statement, root x minus 3 cannot equal 0. Root x cannot equal 3. You'd square both sides. X cannot equal 9. Okay, so x, that would be our domain. Is that our entire domain? And x has to be greater or equal to 0. Okay, so to do the derivative of this one, I would still always recommend taking your radicals and turning them into exponents. So we could do x squared over x to the 1/2 minus 3. Okay, so f prime of x is low x to the 1/2 minus 3. D high would be 2x minus high. D low would be 1/2 x to the negative 1/2, and then minus 3 would be minus 0, so you have to put that all over low squared x to the 1/2 minus 3 squared. Okay, now this one we're just going to kind of keep going and see if we can do any factoring. Now, we can, or simplifying I should say, we can multiply this in. So this is x to the 1, right? So that would be, if we multiply that in, that would be 2x to the 2 over 2 plus 1 over 2, 3 over 2, and then 2x times negative 3 would be negative 6x. And if I multiply this in to here, that's a negative, right? So it'd be negative 1/2 x. Now that's 2 over 2 minus 1 over 2. Oh, sorry, that's 4 over 2 minus 1 over 2, be 3 over 2. And that would be all over x to the 1/2 minus 3 squared. Now we can still, well, we can get these two together first, these two exponents, right, because they're the same. So 4 over 2 minus 1 over 2 would be 3 over 2 x to the 3 over 2 minus 6x all over x to the 1/2 minus 3 squared. And just to skip actually, I'm not going to do that right now. Okay, so what can we can still go, and we can take out, we want to take that fraction, let's take the fraction out front. Okay, now we can do this by dividing 3 over 2 out front. Okay, so move it. So if I take 3 over 2, and I can take out an x to the 3 over 2 as well. That would leave me with x minus, now what's negative 6 divided by, so negative 6 divided by 3 over 2 would be negative 6 times 2/3. That's negative 12 over 3, which would be negative 4. Oh, actually, sorry, we can't take out 3 over 2. We have to take out the smallest exponent, which is x, right? So 3 over 2 minus 2 over 2 would give me 1 over 2 minus 4, and since I took out the x, and then that's all over x, the 1/2 minus 3 squared. And since I've taken it out front, you can also now just bring the 2 down. So that would be 3x times root x minus 4 all over 2x to the 1/2 minus 3 squared. You might in a multiple choice question more than anything. Oh, sorry. Yeah, I shouldn't have done that. So basically, after we did this step, we've just been trying to do some pre-calculus factoring again. Keep that all fresh in our minds. That you don't want to be leaving fractions inside here. Okay, and then you want to take out as many x's as you can. Okay, show that there are no tangents to the curve y equals x plus 2 over 3x plus 4 with positive slopes. Okay, so let's do the derivative. Y prime equals low, d high would be just 1 minus high times d low would be 3 all over low squared. Okay, so this would be 3x plus 4 minus 3x minus 6 all over 3x squared plus 4 squared. Okay, 3x's are going to cancel each other, and 4 minus 6 is negative 2 over 3x plus 4 squared. Now it says show that there are going to be no tangents on here with positive slopes. Well, if you think about it, no matter what number you put in the, well, let's do this first. The top will always be negative. It's negative 2 is not moving. And the bottom will always be positive, right? There's no getting out of that because you're squaring whatever you get inside. And this, of course, equals a negative. We just found the slope. The slopes will always be negative, okay, no matter what. And if you cheat a little bit, like I did to make sure, okay, because this would be negative 4 over 3 would be about here. Okay, the graph looks like this. As you can see, there's absolutely no positive slopes in that graph. So I proved it by showing it in the derivative, and then I verified it by Now you're not going to have that privilege, but sucks to be you. What's that? No, you will. Yeah, we're going to do a whole unit on how to draw an entire graph by not using a calculator. But that's not for a couple units. We have a lot harder ones before that. Okay. Number 5. This one is just using f of x. So this one would definitely help you understand or verify if you know how to do the derivative. So y prime is low, d high would just be f prime of x minus high, f of x, d low, be 8x, all over 4x squared squared. Okay, let's just go and try and simplify this a bit. You can take out the top, you can take out a 4x, right? Leaving you with x, f prime x, minus 2 f of x. Oops, not f prime, f of x. And that's going to be over 16x to the 4. Now again, we're just going on to simplify these. In case this is a multiple choice question asking you to do the derivative and then match it up. So the 4 and the x would cancel. 4 with here would be a 4, and then x, this would be a 3. So you'd be left with x, f prime of x, minus 2 f of x, all over 4x cubed. That makes sense? Yep, I just had to check. So yours says 6 there, good. So I don't have it written down here, but hopefully I have the same thing as you. We've got 2 tangent lines to the curve y equals x squared plus 3. Is that what you have? Okay. So I'm just going to kind of show you a picture of what it's talking about. You have the word description. Now, x squared, you should kind of remember what x squared is. Plus 3 is we're moving up 3. Okay, so x squared plus 3 would look something like this. And it says, find the 2 tangent lines that would go through the origin and meet the curve. So what we're looking for are 2 lines that meet like this. Yes, sorry. I want the coordinates. That was nice to you. You don't need to know the equations of the lines. Okay? So this is 0, 0. And the place where it actually meets is x, comma, x squared plus 3. Okay, that's where it's going to meet on both of them. X, comma, x squared plus 3. X will turn out negative. If I put negative x in there, then I'm going to... Okay? So that's what I'm trying to find, those points. So believe it or not, what do we call this tangent line to this spot? If you didn't even see the bottom here, but it was cut off right here. What would I call this tangent line? That's the slope at that point. So both of these share the same slope at that point. This line and this curve would have the same slope at that point. So we could find the slope of the curve quite easily, and we can find the slope of the line using, now we're not going to actually find a slope of 8, but we'll be able to find the equation of the slope. Okay? So let's talk about the slope of the curve. Okay, we'll do slope of curve. Or of the function. How's that? Okay? So what would y prime of that curve be? (2x). Okay? That is the slope function. That's the slope formula for anywhere on that curve. Now how are we supposed to find the slope of that line, or those lines? Oops. Now you may have seen this before. y2 minus y1 over x2 minus x1. Okay, and we can call this x1 y1 and this x2 y2. Okay, that's your slope formula, right, for a line. We have the slope formula for a curve is 2x. Slope formula is just rise over run. So the y's would be x squared plus 3 minus 0 over x minus 0, which is just x squared plus 3 over x. So since they share the same slope at that point, find out what that point is. So I'm going to make 2x equal x squared plus 3 over x. So make the two slopes equal each other. Okay, so then I would multiply both sides by x, and I'll get 2x squared equals x squared plus 3. I'm going to subtract x squared to both sides. I'll get x squared equals 3. Take the square root of both sides. I will get x equal plus or minus 3. Or root 3, I should say. Plus or minus root 3. Okay, so the points are negative root 3 comma something and root 3 comma. Okay, how am I going to find? Plug it into the original equation, you should get the y values. So that's just into x squared plus 3. So plug into x squared plus 3, so that would be 3 plus is, so negative root 3 squared plus 3 equals 6, and root 3 squared plus 3 equals 6. So the points negative root 3 comma 6 and root 3 comma 6. Okay, it's all good. Okay, so let's see how much we can get done, and then if we're working hard